Let's look at exercise 5.154. This is 5.154 on page 340. And there we have a function. So just define the function here. It's minus x to the power of 3 and plus k times x squared. We have to have a multiplication sign between k and x. So here we have the function like this. And it says that x should be larger or equals to 1. But we don't need that in cos. We just and then it says determine the 0 points to f. To find the 0 points of a function, we need to find out when the function is equals to 0. This is an equation, so I press this, and I get x is equals to k. That's an answer, and x is equals to 0. So that is the answer on exercise A. X equals to x and x equals to 0. In B, use cos to show that you have a bottom, a minimum point and a maximum point, so on and so on. And then I can try this command here. I'm not sure if it's going to work or whether it's not. So this command here, extra-malpunkt, doesn't always work if you have A or B or K in it. But another way of finding maximum and minimum points is to find out when the derivative is equals to 0. And this is an equation again, so I press this. So I get the x coordinate of each point here. But I also have to find the y coordinate. And then I find by putting the x coordinate, start with this point. When x is equals to 0, we have a maximum or minimum point, or a Trassepunkt, and I put 0 into it to just find the y coordinate, which is 0. So this will give me the point 0, 0. Just write the answer like this. Don't do this in the test, but this is a maximum or minimum point, right? But I'm not sure if this is a max or a min, so I have to check the mood at 0 o'clock. Put the x coordinate into the second derivative. I see that this is positive, and they should say that k is larger than 0 here. So that's a mistake. I think they mean k is larger or equals to 1, maybe. I don't know. I have no idea. But they should have said that k is a positive number, because if we don't know if this is positive or negative. But they should have said in the text. So I get a positive answer here, which means that the graph is smiling. So this point A, which I just wrote down here, is a minimum point. And then the other point, x is equals to 2/3. I have to find the y coordinate here. This is the y coordinate, right? Which we see. No, sorry, I forgot the k. 2/3 times k was the x coordinate there. And then we get this y coordinate, and we see that that is correct according to the exercise in the book here. So this will be the y coordinate, and I just need to check that this actually is a maximum point. So I should not get angry function when I put in this x coordinate here and I get a negative answer. So this is only angry. So now I have actually shown exercise B, right? To find a maximum point, put the derivative equals to 0, get the x coordinate, then I can find the y coordinate as we always do, and then I check the mood to see if it is a maximum or minimum point. Then it says in C, use cos to determine the equation of the tangent line in the point 1 f of 1. So then I just need use the command tangent, and tell there's the x coordinate of the point, which is 1, and then the name of the function, which is f, and I have to go down here and I see this is the tangent line. And it says write the equation on the form y is equals to ax plus b. So I'll just write it here. So I have to add the terms with x here. So I get y equals 2, and we see that I have 2kx minus 3x, and this I can actually write like this. I have 2kx minus 3x, so I have this 2k minus 3 times x. Do you agree? If I multiply x in here, I will get these two terms. So these are the terms with x. So a here, the gradient, the slope is actually 2k minus 3. And then plus the constant term, terms without x, which is 2 here, minus k. So this is a strange function here, but this is the slope, 2k minus 3, and 2 minus k is the constant term. So this is a, and 2 minus k is b. Okay. Then we done exercise C, and so this is the answer here in exercise C. And exercise D, use cos to and show that the instantaneous rate of change to f when x is 1 is always bigger than the average rate of change from 1 to 2. All right. The momentary rate of change is this a here, 2k minus 3. Okay. So let's find the average rate of change from 0 to 2. Okay. Then I make 2 points. I find a point when x is 0. This point I already have. This is a. Okay. That's a equals 2. And I'll probably call it something else since I already gave it. This was b. Then I make a point c. That is when x is 2. And I have to find a y coordinate. And I can then just write f of 2. So I write 2 f of 2. So here is point c. And then I can make a line, use the command linear between b and c, and I get this function here. And here we should see that the slope here is 2k minus 4 times x. The constant term is 0, but the slope here is 2k minus 4. Okay. And the slope of the tangent line is 2k minus 3, right? So this is difficult, but the slope of the tangent line is 2x minus 3. The slope of the line between B and C, which is the average rate of change, is 2k minus 4. And of course, this 2k minus 4 is less than 2k minus 3, no matter what k is. So this shows that the instantaneous rate of change is larger than this. Okay. So that was the answer. Really difficult exercise 5.154.